Okay, so this video is trying to get everyone up to speed in terms of the sequences and series work we've been doing for C1 and C2. What my aim to do is, over these success videos, is just to kind of reinforce what my double students were talking about in their video, and build on that, and to try and, you know, get you familiar with the traits of each individual type of sequence or series. Now first let's define, before we do anything, what a sequence or series is. So a sequence literally means if I have a list of numbers separated by commas, and they could have a relationship. So here's just consecutive numbers, one plus in one each time. Here we have plus in two each time, okay, but they are separated by commas. That is a sequence, whereas a series would be when they are all added together. So each term is separated by a plus or minus sign. So you can see here plus 2, plus 2, plus 1, plus 1, plus 1. And then from this one here, let's make that 14. So I've got minus 8, minus 8. Do you see? So the difference between a sequence and series is that a sequence is separated by commas, so it's a list of numbers, whereas a series is separated by plus or minus signs, because a series can be added up. Okay, that's why you have a sum of the series. Okay, so there are three types of things that you need to know: recurrence relation, arithmetic series or sequences, and geometric series or sequences. Each of them have their own specific traits, and that's what we need to be able to identify and recognize. So in brief, a recurrence relation will always come in the form of UK plus 1 equals some variant of just a regular UK. Okay, so they'll give you a first term normally. Let's make that clear. So this is small k plus 1 subscript and a small k, and it could be some relationship like this, and they give you a first term u1 equals, for example, 2. This is an example of what a recurrence relation could look like. And basically, a recurrence relation means that the next term, so the next term is this UK plus 1 business, is some variant of the previous term. And we're going to see this in a second, okay? But whenever I see a UK plus 1 or a UN plus 1 or an XN plus 1 or anything with a something plus 1 subscript, I'm like, right, bang, that's recurrence relation. Arithmetic series is when you have arithmetic series, however, remember these things are three totally separate things. Recurrence relation is C1 and arithmetic is C1, sorry. It's also C1, whereas geometric is C2. Okay, but I think it's a good idea to introduce them to you kind of together, except they are three very separate things. So arithmetic is, for example, a series where I'm plussing or minusing a common difference each time. So I am plussing or minusing a common difference each time. You can see how this is plus 1, this is plus 1, this is minusing 4, minus 4. So each term there is something common going on between them. A geometric series, however, is when something is times by a common ratio each time. So still pluses or minuses because of a series, but the relationship between each term, 1, 3, 9, 27, you can see each term has been times by 3, times by 3, times by 3, or it can be divided. So let's say 40 minus 20 plus 10, you know, the relationship is times minus a half times minus a half. Do you see? So geometric is when you're timesing something each time. Arithmetic is when you're plussing or minusing something each time, whereas a recurrence relation is building up your new terms based on some relationship on your old terms. So let's have a look at an example. It says for each sequence, find the first 4 terms, and if the relationship has one, find the limit L of convergence. So normally with recurrence relation we are talking about sequences. Okay, because I have this xn plus 1, I'm straight away, yep, this is a recurrence relation. So let's do this first part, find the first 4 terms. So I've got the first term, x1. Now I want to find the next term, which is x2. So this is x1 plus 1, which is x2, equals 2 times the previous term, x1, all divided by 5. And this is how it would be written. We know that x1 is actually 2, so this is 2 times 2 plus 1 over 5, which is 1. Then the next term, x3, because now this is x2 plus 1, which gives me 3. So x3 becomes 2 times the previous term, which was x2 plus 1 over 5. So that's 2 times the previous term was 1 plus 1 over 5, which equals 3 over 5. So that's the third term in the sequence. Let's find the fourth term. 2 times the previous term plus 1 over 5. Previous term was 3 over 5 this time. So remember, this is C1, so you would not get calculators to do this, yeah? So we need to work stuff out in our heads. So this then would be 6 over 5 plus 1, which is 5 over 5, so that's 11 over 5 divided by 5, which is 11 over 25. So we found the first 4 terms. Now the point is, well, that was the first section answered, but now we need to answer to this finding the limit, okay? So finding the limit of convergence means that this recurrence relation is either going to keep escalating in size as the terms go up, or it's going to start merging into one number, okay? Now you can see here that we started with x1 is 2, then we had a gap for x2 of 1, 2 between 1. Now our gap between the second term and the third term is 2 over 5. And then here we've got another gap which is an even smaller gap. So what's happening is, as the terms go on infinitely long, the difference between each term is becoming smaller and smaller and smaller and smaller and smaller, until it's going to converge towards a limit. So that, let's say, the millionth term then, the millionth term is going to come out as a number the same as the millionth and first term, okay? Because each time we go on, the difference between the numbers will get so small that you'll basically be producing the same number, infinitesimally close. Now the way to prove that algebraically is to use this notation of the limit L. And what we can do is we can replace all xn's or xn plus 1 by L. So check convergence, and if we get a value for L equals, then it must converge to a limit. So let's replace L's for our un plus 1 equals 2, now for our xn plus 1, sorry, 2xn, so 2L now, plus 1 divided by 5. Do the algebra, times by 5, 5L equals 2L plus 1, bring the L's over, and therefore the limit of convergence is a third. So the millionth term, as we go on for infinite, let's say the millionth term is a third, and the millionth of first term will be a third, and the millionth of third, second and third. It will just keep producing a third each time. Okay? Let's try again. This time I have, wow, a un plus 1. I've got something n plus 1. Must be another limit of convergence. It must be another recurrence relation, sorry. Okay, another recurrence relation. So let's find the first 4 terms. I've got the first one. My second term, which is u1 plus 1, is 10 minus the old term, the one before it, u1 over 4. We know u1 equals 4, so that's 10 minus 1, 9. u3 equals 10 minus u2 over 4, which equals 10 minus 9 over 4, which equals 40 over 4 minus 9 over 4, which is 31 over 4. Finally, the fourth term, 10 minus u3 over 4 equals 10 minus 31 over 4, 40 over 4 minus 31 over 4 equals 9 over 4. Okay? So again, you can see that the gap is closing between each terms. I found the first 4 terms. Let's then check convergence. Okay, so check convergence. Remember, replace all UNs and UN plus 1. Doesn't matter if it's UN or UK or XN, doesn't matter. As long as I've got this n plus 1 relationship involving the previous term, it's a recurrence relation. Right, so let's do this. We need to get rid of this 4 on the bottom, so I'm going to times everything by 4. 4L equals 40 minus L. Bring the L's over. 3L equals 40. Therefore, the limit is 40 over 3. Last example then. Again, I've got this UK plus 1. Must be a recurrence relation because it involves the previous term UK. I could find the first 4 terms, but I'm not going to do that this time. I just want to check convergence this time. And I'm going to prove that this thing won't converge. And you'll see why. Instead it was going to diverge because I can't get an L equals. So replace everything by L. Put all the L's on one side. I get L minus L equals 4, which means 0 equals 4. But that's ridiculous. 0 does not equal 4, does it? 0 doesn't equal 4. This sign means does not equal 4. So this recurrence relation doesn't converge. It diverges, which means it's just going to keep escalating and escalating and escalating as the terms go on infinitely long. It will not converge to a single term. Okay, the next video then is going to be regarding arithmetic series.